Okay, first part, determine whether each relation, so relationship is just relation is a relationship between an x and a y. So figure out if it's a function. So if it's a function, for each x, there's one unique y. So in other words, you couldn't have an x that, such as 5, go to 3, and an x such as 5 go to 2. Because this is the same x, but it has two different y's. That would be not a function. So we're going to figure out if it's a function or not, and then find the domain and range. So domain is all the x values, and the range is all the y values. So this first one, I'm looking at the x's, and it's not a function because 5 goes with 0 and 5 goes with 2. So I'm going to write no. So the domain is, I'm not going to write all of them out for this, but the domain is going to be all the x values. So what you want to write it, you want to usually write it in set notation with brackets. And then you write the x's, so this is the domain. So you're going to write the x's from least to greatest without repeating them. So the least x, the lowest number, is 1. For the x, the next one is 3, then you have 5. I don't need to write 5 twice since it's already on here, 5 and 5, so I'm going to write it once. 5 and 8. And then the range is all the y values. So the range from least to greatest is 0 and 1, 2, 3, 8. 0, 1, 2, 3, 8. Oops. So that's how you write it. You write it in set notation. So number 7. Let's look at our x's to figure out it's a function. Yes, it is. Even though these are negative 6 and 6, it doesn't matter. They're still different numbers. So then you can go ahead and write out the domain from least to greatest is the x's, and the range, write out the y's from least to greatest. And you can also have a graph. So on a graph, you can use what's called the vertical line test. So if you draw vertical lines and you pass through more than one point, it's not a function. So if I drew vertical lines through all of these, you'll notice that right here I passed through 2 points, so it doesn't pass the vertical line test. So no, this is not a function. It also doesn't pass the vertical line test because if this was the point -1, there would be -1 and 1 and -1 and -3. So it wouldn't work. So then for the domain and range here, you're going to write out each of these ordered pairs. So this one's -2, 2. So write out all the ordered pairs around here. So this looks like 1, 1/2, and list off all the x's from least to greatest and the y's from least to greatest. This is a mapping, so the ordered pairs are -4, -1, -2, 2, -1, 2, 1, 4, 3, -1. This one is yes, it's the function because all of these x's are going to just one number. This one is still a yes, a function, because all of these x's are going to, there's not 2 y's for 3. There's not 2 y's for 1/2. So that's why it's yes, a function. And this notation means that you need to plug in -2. So I'm going to write f of -2 equals negative. Now I'm going to plug in -2 plus 4. So this is going to be f of -2 equals 2 plus 4 is 6. And then you can go ahead and plug in -2, -1/2, and 3. So what I do is, to answer whether it's supposed to be in decimal or fraction form, if you're given a decimal, your answer can be in decimal. But if I'm given a fraction, I don't want to answer as a decimal. So that's just something to keep in mind. Let's do a fraction one right here. So I'm going to do f of negative 1/2 equals 3/8 times negative 1/2 minus 3. So it's going to be f of negative 1/2 equals, multiply across. I don't see anything that I can reduce right now. So it's negative 3/16 minus 3. So in this case, because we started with a decimal, go ahead and put this in your calculator and answer as a decimal. Okay, then the next part, write in standard form. So standard form is you have x and y on the same side and your constant separate. And these needs to be integers, so that means you're going to have to clear fractions. So to put in something in standard form, you want to put it in point slope form first. So I'm going to write it in point slope form. So point slope form is y minus y1 equals mx minus x1. So you have your slope right here, and you have your point, your x1 and your y1. So I'm going to substitute those in. So it's y minus 4 equals negative 3 times, oops, I already messed up. Y minus 0, because that's my y, equals negative 3 times x minus 4. So I'm going to do the distributive property. So it's negative 3x plus 12. So right here is in slope-intercept form. I want to write it in standard form. So I need to get x and y on the same side. So you usually want to write, most teachers will want you to write the x first. So you write 3x plus y equals 12. So you start at point slope form, and eventually you get to slope-intercept form, and then you end with standard form. So this one, I have 2 points, so I can get my slope. So I'm going to do 5 minus 3, use the slope formula, over 3 minus 2. That's my slope. Now, you can pick either point, it doesn't matter. So I'm going to pick this one. And I'm going to write it in point slope form. So it's going to be y minus 3 equals 2 times x minus 2. So it's y minus 3 equals 2x minus 4. So I'm going to get my constant on one side, and I'm going to move my x over on the other side. So it's going to be negative 2x, this is cancel out, plus y, because this is a positive y, equals negative 1. That's in standard form. Okay, then down here, write an equation of a line that is parallel. So parallel lines have the same slope. So I need to find the slope of this line first, so I'm going to write it down here. So to find the slope, you want to solve for y. So it's going to be, I'm going to subtract x, so I'm going to get 2y equals 6 minus x, and divide both sides by 2. This is going to be 1/2 x. So my slope is negative 1/2. And my point is 8, 3. So I'm going to use the point slope form and do y minus 3 equals negative 1/2 x minus 8. It doesn't specify which type of equation I'm going to use, but so I'm just going to use point slope. And the second one is perpendicular. So perpendicular is the slope that's perpendicular is the opposite reciprocal. So the opposite is going to be positive and the reciprocal is going to be 2. So now I'm going to do y minus 3 equals not negative 1/2 but 2 times x minus 8. And then down here, for each function, determine whether y varies directly with x. So y varying directly means that your equation is going to be a linear, direct variation is a special linear equation where there's no y, the y-intercept is 0. So in order to get y, you just need to multiply x by the exact same number every time. So what you want to do is to see if there's a constant k. So to solve for k right here, I'm going to do k is equal to y divided by x. So if these are direct variation, then y divided by x is the exact same every time. So I do 3 divided by -2, 4 divided by 0, can't divide by 0, 7 divided by 2. Are all of these numbers the same? So in other words, if you take x, can you multiply x by the same number every time to get this y? No, these are different. So no, this is not direct variation. So I'm going to check the next one. So 5 divided by 4. 9 divided by 6. Well, that's 3 halves, and this is not 3 halves, so I already know that no, it's not direct variation. And then 0, 0 you kind of want to not work with because that's just, you don't want to divide by 0, 0 is not going to get you anywhere. But it could be direct variation because remember, direct variation is a special line and it goes through 0, 0. So now I'm going to check the rest. So 1 divided by 1 is 1. 5 divided by 5 is 1. So it is direct variation. So the equation for direct variation is y equals kx, and then our k is equal to 1. That's what we just found. So your equation is going to be y equals 1x or y equals x.